So today we're going to deal with estimating and rounding off. Let's go to the beginning of our lesson. Now, estimating is an important part of mathematics and a very handy tool for everyday life. Estimation is a useful tool for finding approximate answers to mathematical equations. And in this lesson, you can learn the rules for estimation and practice estimation and rounding off. Now, your question might be, what is the difference between estimation and rounding off? Now, the answer is simple. Rounding off, in fact, is a form of estimation, a more accurate form of estimation. And we will have a look at both estimation and rounding off. Now, estimation makes it easier for us to add, to subtract, to multiply or to divide, especially when we're doing mental arithmetic. Now, of course, if we're estimating and if we're rounding off, we're not going to get the exact number. But what we want to arrive at is a number which is maybe not exactly correct, but which is still usable. So in other words, we're looking for an answer which is close enough to the right answer. Close enough for what? For example, we might be going to the shop and we might have a specific amount in our hands, cash in our hands. We can only buy for what we have in our hand, and we see some articles on the shelf and we might think, okay, I'm going to have the baked beans and the bacon and the eggs. I wonder whether I have enough money to pay for all three of those articles. So these three articles might be priced with a very complicated price, such as $3.63, and that is very difficult to add to $2.51. So you round off the numbers so that you can easily add it together and decide whether you can afford the three articles you want to buy. Here is an example. You want to buy 5 magazines that cost $1.95 each. When you go to buy them, the shopkeeper with a straight face tells you that will be $12.25. Thank you. And you go, I wonder, that doesn't sound right to me. Let's think about this. 5 lots of $1.95 is about 5 times 2. So if you look at the $1.95, you can see that it is approximately, let's work in black, it is approximately two. Sorry, no, not the 12. Let me just getting a bit confused here. So the $1.95 is approximately $2. I'm going to ask you to excuse me for 1 minute. There's someone outside making a noise, and I don't want that to interrupt our class. Please hold on. I apologize for that. And I see there was a okay, no questions yet. So we are now busy with this amount, $1.95, which is approximately $2. You can also see that I'm working with the same sign, a strange sign here. It looks a little bit like the is equal to sign, and it means is approximately the same. So $1.95 is approximately the same as $2. So now it's quite easy to calculate this amount. It is 5 magazines. We want to buy 5 magazines, and they cost $1.95 each, and it's approximately 2. So it's 5 times 2, and it is approximately $10. And now you can tell the shopkeeper, oh, sorry, sir, but no, I don't think that can be the correct amount. So this little example shows you that estimation helps you with confidence, judgment, and decisions. Let's have a look at another example. Say, for example, you want Galaxy, you have raised your hand. Hello, Galaxy. If you have a question, then please post it into the chat box. So we're looking at this example. Say you want to buy 3 pairs of pants and 3 t-shirts for summer, and you have $150 to spend in total. Okay, you have $150 to spend in total, and you find the style you really like, and you decide to buy 3 pairs of pants and 3 t-shirts equally of the same size, the same style, and the total that you can spend is $150. Now, suppose 1 pair of pants costs $14.72 and 1 t-shirt costs $1.5. So you can see that that is quite a difficult calculation to make. You have to take the price of the pants for $14.72, and you have to multiply it by 3, and to that you have to add the price of the t-shirts, and that is $11.5, and you have to multiply it by 3. So if you have a calculator, you can calculate that quickly, or you can quickly estimate. You can say that $14.72 is approximately, remember that this is the sign for approximately. It's a little bit like the is equal to sign, but not exactly. And that is approximately, this is not too far from $15. I see Galaxy has raised his hand. Galaxy, I know you from last time. Welcome back in the classroom. So that's $15 times 3. And we're going to add 50 cents to, we're going to round this one off to approximately $10. And that we also have to multiply by 3. So this will then be equal to 15 times 3 is $45 plus $30. And you can see that the answer there then is $75, which is much easier to calculate than what it is to add all of this together. Okay, so these are just introductory examples. We're going to get down to brass tacks a little bit more now, and you will also have more of an opportunity to help me to find answers to the questions. Now, how are we going to estimate? Before doing the actual calculation, you have to think about how to go about estimating the total. If we look at our previous example, I said that is about $15. So I increased the amount slightly. And this is about $10. So I decreased the amount slightly. So this increased, this decreased, so I know that it should be approximately be the correct answer. Now there are different methods we can use. For example, if we have to add 550 to 298, 298 is nearly 300. So we can say 550 plus 300 is 850. Very easy to add these two. And we can do it in another way. We can take the hundreds. The 2 and the 5, and we can add them together. That will give us 700. In other words, it's 500 plus 200, and then we can go and we can add the 50 and the 48. But this 48 is very close to 50. So we can say that that is approximately 50. And then, of course, we have to add the 50 plus 50, which is 100. 500 plus 200 plus 100 is 800. In one case, it seemed easy to change one number and then add, and in another case, I added the hundreds together and then increased the result by 100. There's no right way. So whatever works for you is fine. But, you know, if you want to improve your maths, What you need is lots and lots of practice. You know, if you want to do well in history, then you have to study the facts and you have to interpret the context within which those events happened. If you're studying English, you have to practice creative writing. For math, what you have to do is practice, because if you practice, you develop an instinctual feel for the numbers, and there's absolutely no substitute but practice. Okay, now we're going to look at rounding off. How are we going to round off decimals? Our first example here, round off the following number to 2 places after the point. So let's go count 2, and then 1 place after the point, 2 places after the point, 3 places after the point. So 2 places after the point is 4/100, or 0.04. Now, if we look just to the right of the 2, I just want to add at this stage that sometimes there's a problem with the document which is shared. So if the shared document disappears, please comment on this in the chat box. I again repeat, if you want to communicate with me, write in the chat box. Back to here. So we have to round off to the green digit, which is 2 places after the decimal point, and that is 0.04. How are we going to do this? We're going to look at the place value just to the right of the hundredths place value. This is the hundredths place value, and this is the thousandths place value. And this one is going to guide you to see whether the 4 has to become 5 or whether it has to stay a 4. So what are we going to do? We're going to have a look whether this 2, this purple 2, is smaller than 5 or bigger than 5. Or to be exact, smaller than 0.005, and it's smaller, or so it's smaller than 0.005 or bigger or equal to 0.0005. I see there's a question. Let me quickly check what the question is. Now, in this case, you can see that the 2 is in fact smaller than 5. Because it is smaller than 5, it is not going to change the value of the green place value. And we're going to round off this number to the 4, so it's going to stay 4. Can any one of you give me an idea of what the answer would be. Yes, there's a question whether you should round, whether you should check the value before rounding off. Yes, you have to check the value before rounding off. So let me just quickly explain again how you do this. You go to the number which you have to round off. In our case, it will be the green value. We have to round off 2 places after the point. So then we go to the number to the right of this number, the purple number. We see whether that is smaller than or bigger than or equal to 5. If it is smaller than 5, then this value stays the same. If it is bigger than 5, then this value goes up with 1. So anyone with the answer? Okay, the answer will not be 2.3. Someone posted an answer with 2.3. I just quickly want to explain why that will not be. Get my pen functioning. So the suggestion is that the answer here is 2.3. Or, so in other words, we will be rounding off to 1 point after, to 1 place after the point. This is not correct because our task is to round off to 2 places after the point. In other words, this is the number which we have to round off. I see that there's an answer from P. I can't see your name in full, but your answer is 2.34. Thank you. 2.34. So you can see that for the purple placeholder just becomes 0, the 3 becomes just 0, and the 4 becomes just 0. And of course, we're not going to write down the zeros. We're just going to leave them out because it's after the decimal point. So the answer is 2.34. Thank you, P. Okay, let's move on. So now we have another example. It's the same number, sort of, but you can see that the number in the thousands placeholder has changed. So what do we have to do now? We have to look at the purple placeholder and we have to see whether it is. Can anyone help me? Any answers? We have to see whether, just get my pen to function. We have to see whether this placeholder, the thousands placeholder, is smaller or bigger or equal to 5. In this case, you can see that the 6 is bigger than 5, and therefore this 4 is going to increase with comma 0, 1. So we're going to add 1 to this placeholder. Can anyone give me the answer, please? Thank you. I see that there's an answer of 2.35. Exactly. Thank you. And of course, this is just going to fall away, and that is just going to fall away. Thank you. Now, we're going to work with rounding off the whole numbers. So we're going to round off 2,364 to the nearest 100. So if we look at this number, 2,300, so this is the hundredths place value, and then 64, 60 is the tens placeholder, and 4 is the ones placeholder. So we have to work with the 3 because we have to round off to the nearest 100. And 3 is the place value of the hundreds. We're going to look at the yellow 6. This yellow 6 will guide us to whether we're going to increase this 3 with 1 or whether we can going to leave it exactly like it is. Now, 6 is bigger than 5. And can anyone please give me a guesstimate of how much we're going to round off this amount, this number to? Any answers? Thank you. I can't read your name there, but you said that 2,364 rounded off to the nearest 100 is going to be 2,400. Exactly right. This 4 falls away and becomes a 0. The 6 falls away, becomes a 0, and the 3 becomes a 4. Thank you. No questions? Now, if the original number was 2354, the answer would still be 2400. If the number was 2314, the answer will be 2300, because if it's smaller than 5, you leave the 3 as is. Let's now do a few exercises. Now, this is what we have here. This is our number 356 0.530. And our task is to round off the following number to 2 places after the decimal point. So it's 356 whole numbers, 0.532, 5 tenths, 3 hundredths, and 2 thousandths. And we have to round off to 2 places after the decimal point. So the yellow 3 is the one which is going to change or not change. And you can see that the 2 is the purple one. If the 2 is smaller than 5, the 3 stays the same. If the 2 is bigger than 5, then this 3 is going to increase with 1. Anyone who can give me the answer for this problem? Thank you. Let me just enter that. 356 point, oh, sorry. Mess up. Pen who doesn't want to comply to instructions. Let me try again. So this then will be 5 and 3. Please take note that this will not increase with 1. It will not be 5.54. 4 is not the correct answer because the 2 following the 3 is smaller than 5. Exactly, yes. Another one. Okay, so round off the following number to 1 place after the decimal point. So in the previous example, we rounded it off to this 2 places after the decimal point. Now we're going to round it off to 1 place after the decimal point. So we're going to look at towards the 3 to see whether the 5 is going to increase with 1 or not. I can see some of you have already answered. Thank you for that. The 3, of course, is smaller than mess. Clean up the mess. Is smaller than 5. And therefore, the 5 is not going to increase. And as you said, our answer is going to be 3, 5, 6. We don't change any value here. We leave it exactly as it is. Everything before the point we leave as it is. Point. And this is the place value, the number which we have to change or leave as is. We're going to leave it as is because the 3 is smaller than 5. Now, our next one. Now we're going to work with the hundreds. We're going to work with the whole numbers. I see that some of you are asking for something harder. And luckily, what we're trying to do is to cover from the basics to the more difficult parts of this section. So for the sake of those of you who still don't exactly understand how to round off, I am going to go through the next two examples, just so that everyone can be with us. Okay, so now we're working not with the numbers after the decimal point, but we are working with the numbers before the decimal point, in other words, the whole numbers. And this can sometimes become a little bit confusing. We have to round off to the nearest 100. Now, this is the hundredths column. So it's the 5 which we have to round off. And we're looking towards the 7, whether it's bigger or smaller than 5. And if it is bigger than 5, which I can see some of you have already figured out, if it's bigger than 5, then of course this one is going to increase with 1, so that becomes 6. Thank you, yes, but here is now where the crunch comes. It's 6, but everything to the right of the 6 becomes a 0. And then of course we have the decimal point. And you can either fill in the zeros, or that's not really necessary. In fact, we can actually just write it like this, because there are no numbers after the decimal point. There is no fraction left. Let's have a look at another example. Now let's try rounding off to the nearest 1. This can be a little bit tricky because the 3 is the one with the one that is the digit which we have to round off. And we have 5 and 2 in front of 3. And next to the 3, to the right of the 3, we have the decimal point, and then we have a decimal fraction, 1/10. Actually, absolutely nothing changes here. You have to decide whether the number to the right of the number we have to round off, which is the 3, whether this number is bigger or smaller or equal to 5. It is, as some of you already have said, it is smaller than 5. And therefore this number is the one which is going to not change in this case. And thank you. If, as you said, the answer is 523. Stays exactly as it is, and you can either fill in the decimal point and the zeros, or if you are so inclined, you can leave them out. because you don't have any fractions. And the answer will just be 523. I have another example. Now we have to round off the following number to the nearest one. This one is a little bit more complicated. It is a 5 now. Now, what do we do in the case of 5? Can any one of you tell me? What do we do if it is a 5? Do we round it up or do we keep this number the same? What is the answer for this problem? Anyone? When it is equal to 5, we are also going to round it up. So in other words, this number is going to increase with 1. So this 5 is bigger or equal to 5. In this case, it is equal to 5. And in this case, and therefore, it's going to increase with 1. And thank you. The answer will be 574.000. And once again, we can leave out these digits. Okay, now let's try something more complicated. I just want to stop share here. So this is the problem. You have $200 to spend. You want to buy the following articles. One pair of socks of $52.12. You also want to buy a dress of $122.12, and you want to buy shoes of $59. Now, can you afford to buy these 3 articles with the 200 Rand in your budget? So what we want to do, and this once again illustrates why we use estimation and rounding off. We're standing in the shop, we don't want to use a calculator, and we're quickly going to round off these numbers and see whether we can afford our purchase. Anyone who can tell me what the $52.12 will become if we round off to the nearest dollar? The 52.12, what will the 52.12 become? And that will be approximately, any answers? Nothing in chat? Okay, so we're looking towards the number next to the ones. So we're looking to the number just after the decimal point, the 1, which is smaller than 5. And that will therefore become 52.00. Next, we're going to buy a dress of $122.12. Once again, the 1 is smaller than 5, so the 2 stays the same, and that will therefore become approximately, let's see, you can see there's something in our chat box. Oh, sorry. Let's see what's in our chat box. 122, thank you. Yes, $122. And the last one, the $59 for the shoes. Anyone who knows what that will become? It is in fact 59.0, and that will in fact stay 59. Okay, now what this example illustrates quite nicely is that we have rounded off excellently here. We've all our rounding off. I just want to change this. I've made a mistake here. This is not approximately 59. It is in this case exactly the same number, because there's nothing after the decimal point. Okay, let's go back to where we were. We've rounded off perfectly, and these are our numbers rounded off, but it is still very difficult to calculate. I can't do the mental arithmetic for this. It's too difficult for me. So maybe I've made a wrong choice. Maybe what I should do is rather to round off to the nearest 10. That will be more practical, because then it will be easier to add these 3 together. So let's do that. And you can compare the two. So this was rounded off to the nearest $1. And what we're going to do now is to round off to the nearest $10 and see whether that is going to help. So the 52.12 is now going to become, anyone who can help? If we're going to round off to the nearest 10, what is 52.12 going to become? So this is going to become $50. Because we're rounding off to the nearest 10. In the case of the, thank you, I see someone has already calculated the whole of the problem. This one we're going to round off to the nearest 10 as well, the 2, and we have a 2 next to it, which is smaller than 5, so that's going to become $120. And the last one, thank you, we're going to look towards the 9 to see if the 5 has to increase by 1. We can see that the 9 is bigger than 5, and that is then going to become $60, exactly like you have it. Thank you, X. And when we add this together, we have 0, and it is 6 plus 2 is 8 plus 3 is 13, and it is $2 approximately. Now, what would you advise if you were in this position? Would you advise that I spend my money on these 3 articles, or do you think I should not? What is your answer? Okay, so this, as you can see, I am $30 over budget. I am approximately $30 over budget. One of you suggested that I put one article back. Can any one of you tell me which article I should put back? Should I put the socks back? Should I put the dress back? Should I put the shoes back? Which one? Any answer? So the socks cost 52.12. The dress is 122.22. And the shoes are 59. So which one should I put back? Well, of course, the obvious answer is that you should put back the one which cost the least, the socks, because then you can still spend, you can still get as much as possible for your money's worth. So you can afford the dress and the shoes. So this example illustrated how you use rounding off to make decisions. Thank you all of you for joining me today, and I hope to see you soon again next Saturday. Thank you. Goodbye, and have a lovely day.